Find x. It's right there. Trig done. Trigonometry is the study of triangles, and although it might not seem that important, it's necessary for understanding the world around us, and is probably necessary for your graduation. So let's get started. Today we'll be talking about right triangles and how to solve for missing angles and sides. The three sides of a right triangle are called the opposite side, the adjacent side, and the hypotenuse. If we were solving for this angle in the triangle, the side that's the farthest away would be the opposite side, the side on the bottom would be the adjacent side, and the longest diagonal edge would be the hypotenuse.
If you know two of the sides of the triangle and only need to solve for the last side, you can use the Pythagorean Theorem. And although it might sound scary, it's actually a very easy formula. The Pythagorean Theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. The formula is written as a squared plus b squared equals c squared. In the problem, we know that the lengths of the adjacent and opposite sides are 12 and 5, but we don't know the length of the third side, which is the hypotenuse. For this problem, we'll name this unknown side as c. To solve for the hypotenuse, we can use the Pythagorean Theorem, using 12 as a and 5 as b. So our formula is 12 squared plus 5 squared equals c squared. 12 squared equals 144, and 5 squared equals 25, and when added together they equal 169. Then, by taking the square root of each side, we can isolate c. The square root of 169 is 13, meaning the length of the hypotenuse is 13.
But what if we wanted to solve for a missing angle rather than a missing side? To find a missing angle, we can use three different functions called sine, cosine, and tangent. Sine of an angle equals the opposite side divided by the hypotenuse side. Cosine of an angle equals the adjacent side over the hypotenuse side, and tangent of the angle equals the opposite side over the adjacent side.
In this example, we can use any of the three functions to find our unknown angle. If we were using sine, we would set up the formula as sine of theta equals the opposite side over the hypotenuse side. Using our triangle, this would be sine of theta equals 2.8 over 4.9. To solve for theta, we can use the function inverse sine. That makes our equation theta equals inverse sine of 2.8 over 4.9. When we plug this into our calculator in degree mode, we get the angle equals 35 degrees.
Trigonometry can also be very helpful in physics and engineering. For example, if you were on a ladder and leaning against a tree, you could find the height of the tree just by knowing the height of your ladder and your angle. If your ladder was 8 feet tall and you were leaning against a tree at a 45-degree angle, you could find the other sides and angles of the triangle using trigonometry. To find the height of the tree, you can use the function sine. That makes our equation sine of the angle equals the opposite side over the hypotenuse side. So sine of 45 degrees equals the opposite side over 8. Then all you have to do is multiply 8 to both sides of the equation, which makes 8 times sine of 45 equals the opposite side. When we calculate that out, we get 5.66 equals the opposite side, and that opposite side is the height of our tree.
To find the distance from the base of the tree to the base of your ladder, you can use the Pythagorean Theorem.
Again, the formula is a squared plus b squared equals c squared. That makes our equation 8 squared equals 5.66 squared plus a squared. To isolate a, all we have to do is subtract 5.66 squared from both sides of the equation and then take the square root of both sides of the equation. That leaves us with a equals 5.65. That means that the distance from the base of your ladder to the base of the tree equals 5.65 feet. This has been Simply Science. Thanks for watching.